press the bell icon on the YouTube app and never miss another update.
Hello my dear students, how are you? We feel that in the yesterday class you have understood something which may excited you to learn physics. Don't feel that in just one class you have understood everything. There is a long journey, my dear students. During this long journey, we need a company, a good company from your side, in the sense understanding the things, cooperation with the lecturers, teachers, discussing the things, what the difficulty that you are facing. Along with your parents, you take the lecturers as your parents to understand your things. So don't neglect these 2 years, my dear students. These 2 years will go in a minute. Definitely you have to take the exam. Whether this COVID-19 exists, doesn't exist, you must take the exam. That is the case. Now, this science, in the yesterday class I told there is some microscopic phenomena to macroscopic phenomena. These are the two main domains. Two main domains means concern that exist in physics. One we say macroscopic phenomena, which you feel large. So as we studied in the last class, there is one branch we call as thermodynamics. Along with that, you have something called optics. In this thermodynamics, you will study the construction working principle behind heat engine, Carnot's heat engine, how this works. In optics, in the 10th standard, you have studied some spherical mirror, formation of images, and also in lens formation of images you have studied. That formation of images, how images can be formed, can be understood in the microscope. So that comes to under optics, means large concept, things that comes under macroscopic phenomena, thermodynamics, optics, Newtonian mechanics. To understand motion of objects in the entire universe. Along with that, there are some microscopic phenomena and also some electromagnetism, electricity and the magnetism. Microscopic phenomena. In microscopic phenomena, you will study microscopic particles, say like photons. Light consists of photons. These photons, when interact with the matter, means light is a form of energy which consists of packets of energy which in contact with the matter, solar cells, there is a conversion of light energy into electrical energy. That construction of say macroscopic solar panels. Solar panel is so huge. When a particle like photon interact with such a matter, there is a conversion of light energy, light energy into electrical energy. Photon energy gets converted into electrical energy. Comes under microscopic phenomena. And atoms, molecules, which are very essential in the study of the nuclear phenomena. Phenomenon, you say. Hence there is a construction of nuclear reactor. Nuclear reactor is a huge thing. Study of nuclear phenomena is a huge. But if you go deeper, there exist microscopic particles, splitting of heavy nucleus into its fragments leads to, that is, fragment means heavy nucleus like uranium, when bombarded with slow energetic particles like neutron, that heavy radioactive element splits into its fragments, components, barium and krypton, with the release of tremendous of energy. And that energy released can be used for constructive purpose and for the destructive purpose. Constructive means a nuclear reactor. The nuclear reactor, first nuclear reactor was discovered by Enrico Fermi, which includes the physics concepts, that is phenomena of radioactivity. And the same destruction of heavy nuclei into its fragments leads for the destroy purpose that is happened in Hiroshima and Nagasaki of Japan. That nuclear energy which is released tremendous because of nuclear fission reaction destroyed the living things. There comes under microscopic domains. This is what the two main domains, macroscopic phenomena andreno, microscopic phenomena andreno. For example, you could have you observed scattering phenomena. Raman effect. With the scattering of particles, when a light is incident on certain molecule, the light gets scattered. Wavelength changes. By studying the wavelength or frequency of the scattered light, it is possible to understand the composition, the molecule or the compound present in the given substance, my dear student. There exist microscopic phenomena. Scattering of particles of the light particles get scattered when they are incident on certain molecule. Depending on the nature of the molecule, the wavelength and the frequency of the scattered light will change. By analyzing that spectrum, it is possible to understand the nature of substance that is present. That comes under microscopic phenomena, my dear students. That you will study in detail in coming classes. We are just in the first chapter, physical world. It is only an introductory part. Now the next discussion is, my dear students, is this physics helping the society, means to human living things with the technology? ಅರ್ಥ ಆಯ್ತಾ? ಈ ಫಿಸಿಕ್ಸ್ ಅನ್ನೋದೇನಿದೆಯಲ್ಲ, ನಿಮ್ಮ ಏನು ಜೀವನ ಸಂಕುಲನ ಏನಿದೆ ಅದಕ್ಕೆಲ್ಲ ಸಹಾಯ ಮಾಡ್ತಾ ಇದೆಯಾ? ಎಂಟೈರ್ ಸೊಸೈಟಿಗೆ ಏನಾದರೂ ಬೆನಿಫಿಟ್ ಇದೆಯಾ? ಡೆಫಿನೆಟ್ಲಿ. ನೋಡಿ, ಸಿಂಪಲ್ ಎಕ್ಸಾಂಪಲ್, ಸಿಟ್ಟಿಂಗ್ ಅಟ್ ಹೋಮ್, ಯು ಆರ್ ವಾಚಿಂಗ್ ಆನ್ಲೈನ್ ಕ್ಲಾಸಸ್. Do you know that all the data that is being transmitted, what we are taking the class in front of the camera, all these data is being stored in a just a small, can you view this? It's of around 1.5 centimeter length, 1 centimeter width, and thickness, my dear students, less than millimeter. Thickness ಏನಿದೆಯಲ್ಲ 1 millimeter ಇಂತ ಕಮ್ಮಿ ಇದೆ. ಇದರಲ್ಲಿ ಸುಮಾರು ಹಬ್ಬ ಅಂದರೆ 12 ಕ್ಲಾಸ್ಗಳು, 12 ಕ್ಲಾಸಸ್ ಇಷ್ಟರಲ್ಲಿ ಸ್ಟೋರ್ ಮಾಡ್ತಾರೆ. ನಾವು ಬರೇ ಮ್ಯಾನ್ಯುಯಲಿ ಮಾಡ್ತೇವೆ, ಬಟ್ ಇಲ್ಲಿ ಟೆಕ್ನಾಲಜಿ ಇದೆ, ಫಿಸಿಕ್ಸ್ ಇದೆ, ಇಂಟಗ್ರೇಟೆಡ್ ಟೆಕ್ನಾಲಜಿ ಇದೆ. ಸ್ಮಾಲ್ electronic components are integrated, combined together in a small area. Can you say there is a physics or not? There is a physics. And this physics has helped the technology, and that technology reaching the society now. They may ask, give an example that how physics is linked, connected connected to society. Explain with one example. So with the help of this scattering phenomena, Raman effect, in this Raman effect, there is a technology, there is a scattering phenomena, there is a physics in which it is possible for the scientists to analyze what the size, shape of the molecule, the nature of compound that is present in the given substance can be understood, my dear students. Our scientists, Indian scientists, have launched so many Earth satellites, geostationary satellites, which revolve just closer to the surface of Earth and gives a lot of information around us. There are polar satellites also, and these polar satellites revolve around the Earth in polar regions. Many times, they take many rounds in a day and scan the places where, in the remote places where the person cannot go there. They take the picture and they give some data, they collect the information by the photography and they transfer to us. Means there is some physics, and with that physics our scientists have developed some technology, and that technology is reaching us. Sitting at home, just by having a mobile in your palm, the entire world can be scanned, my dear students. In a fraction of a second, you can reach wherever you want, provided network should be easy mode. It should not be very busy. ಕನೆಕ್ಟ್ ಮಾಡಿದ ತಕ್ಷಣ ಚಂದಾದಾರರು ಈ ಕ್ಷಣದಲ್ಲಿ ಪ್ರತಿಕ್ರಿಯಿಸುತ್ತಿಲ್ಲ ಅಂತ ಬರಬಾರ್ದು ಅಷ್ಟೇ. ನೆಟ್ವರ್ಕ್ ಬ್ಯುಸಿ ಇರಬಾರ್ದು. ವಿತಿನ್ 10 to 15 seconds you can reach that spot. Means once the connection is quickly connected, within fraction of a second you can view that place where you want, what the data you can collect. But my dear students, this technology has made some benefit to the human lives. It has given good things and also the bad things. Depends on the mindset of the user. ಒಳ್ಳೆಯದಕ್ಕೂ ಬಳಸ್ಬೋದು, ಕೆಟ್ಟದಕ್ಕೂ ಬಳಸ್ಬೋದು ಅದನ್ನು. ಅದು ನಮ್ಮ ಕೈಲಿದೆ. So this discussion is how physics with the help of technology helped the society. And many things, my dear students, you will get. ನಾನು 3-4 example ಕೊಟ್ಟಿದ್ದೀನಿ, ಅದಿಷ್ಟೇ ಅಂತಲ್ಲ. You must have a mind that this physics has, for example, in the study of microorganisms, we need a microscope, compound microscope, and electron microscope, which gets magnified images. Can you say in the construction of microscope there is a biology? No. In the construction of this microscope, there is a physics behind it. There is a use of lenses. There is a particle accelerator in case of electron microscope. In case of electron microscope, we need particle accelerator. Electron has to be accelerated. In case of compound microscope, where we cannot use electron, we must use light as well as lenses. Instead of light, we use electrons, which show which are particle in nature, show wave nature in the construction of electron microscope. In the last class, briefly I explained. So with all this, we must have something that physics leads to technology, or behind a technology there is a physics that has helped our society, and we should take the positive things of the technology, and that technology has to be used for the positive purpose, for the constructive purpose, not for the destructive purpose, my dear students. I hope you understood this. So in the last discussions of this chapter, my dear students, there are some fundamental forces that exist in nature. Can you name them? Basic forces that exist in nature. Fundamental or we say basic forces in nature. My dear students, you just take along with this me. ನಾನು ಬರಿತಾ ಹೋಗ್ತೀನಪ್ಪ, ನೀವು ಕೂಡ ಬರಿತಾ ಹೋಗಬೇಕು. First one is nature of force. Their relative strength. And their existence. Means how we say, where do they exist? Interactions. Means where do they find? ಎಲ್ಲಿ ಬರುತ್ತೆ, ಎಲ್ಲಿ ಕಾಣಿಸ್ತದೆ ಅಂತ. Very first we can take nuclear force, weak nuclear force, electromagnetic force, and last one, gravitational force. So what are the four fundamental basic forces in nature? You can take this as a basic force or the fundamental force. Itself it indicates a nature, what type of nature it is. What I have written is not wrong, it is correct also. We can understand basic forces or fundamental forces. Nature is nuclear, weak nuclear, electromagnetic, gravitational force. You have to remember in this order only or in the reverse order. But in the writing relative strength, you should be very careful about this. You should remember this number, my dear students. 1, 10 to the power of minus 13, 10 to the power of minus 2, and this is about 10 to the power of minus 38. Okay. This existence means nuclear force exists between nuclear particles like proton, neutron and neutron, proton. The force that exists between proton, nuclear particles, that is inside the nucleus. Weak nuclear force that exists between elementary particles. Like neutrino, antineutrino, and electrons and positrons. This type of force exists between elementary particles like neutrino, antineutrino, electron, beta plus is positrons. This electromagnetic force exists between charged particles. This I can write. Last, gravitational force, which is about 10 to the power of minus 38, that comes between a small particles around us and heavenly objects. Between small objects around us and heavenly, or we say celestial bodies. Means in this data, among this, if you observe, the least value is a 10 to the power of minus 10. Relative strength means, suppose if I compare this gravitational force with nuclear force. Nodi, the relative strength ಚೆನ್ನಾಗಿ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. Relative strength ಇದು 1 ಅಂದ್ರೆ with respect to if I observe with gravitational force, 10 to the power of minus 30 is so negligible compared to this one. ಈ 1 ಮತ್ತು 10 to the power of minus 38 ಇಲ್ಲಿ ನೋಡಿದ್ರೆ 10 to the power of minus 38 negligible, almost zero. That means nuclear force is the strongest force. Sometimes we write this as strongest nuclear force. Among these 4 fundamental forces, there are 4 fundamental forces. Nuclear force, ಇಲ್ಲಿ ನೋಡಿ ನ್ಯೂಕ್ಲಿಯರ್ ಅಂತ 2 ಸಲ ಬರೆದಿರ್ತೀವಿ ಕರೆ, ಅದರಲ್ಲಿನೇ ಮತ್ತೆ ಸ್ವಲ್ಪ ಫಸ್ಟ್ ಒನ್ ಸ್ಟ್ರಾಂಗೆಸ್ಟ್ ಅಂತ ಬರ್ಕೊಂಬಿಡಿ. ಸ್ಟ್ರಾಂಗೆಸ್ಟ್ ನ್ಯೂಕ್ಲಿಯರ್ ಫೋರ್ಸ್, ವೀಕ್ ನ್ಯೂಕ್ಲಿಯರ್ ಫೋರ್ಸ್, ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೋರ್ಸ್, ಗ್ರಾವಿಟೇಷನಲ್ ಫೋರ್ಸ್. ಅಮಂಗ್ ದೀಸ್ 4, nuclear force is the strongest force, whereas gravitational force is the least force, my dear students. But if I compare with this, say nuclear force with electromagnetic force, nuclear force somewhat, electromagnetic forces they are somewhat near. Means if I take the ratio, say nuclear force to this electromagnetic, we call as Coulomb force, that is 1 divided by 10 to the power of minus 2, 1 divided by 10 raised to minus 2, numerator ratio ತಗೊಂಡ್ರೆ 10 to the power of 2 you will get. So nuclear force is 10 to the power of 2 times the Coulomb force. ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿಕ್ಕೆ, ನ್ಯೂಕ್ಲಿಯರ್ ಫೋರ್ಸನ್ನು ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೋರ್ಸಿಗೆ ಚೆಕ್ ಮಾಡಿದ್ರೆ 1 divided by 10 to the power of minus 2 ಮೇಲೆ ತಗೊಳ್ತೀರಿ 10 to the power of, ಅಂದರೆ ನ್ಯೂಕ್ಲಿಯರ್ ಫೋರ್ಸ್ 100 times greater than the electromagnetic force. ಹಂಗೆ ಇದು ರೇಷಿಯೋ ತಗೊಂಡ್ರೆ 1 divided by 10 to the power of minus 38 ತಗೊಂಡ್ರೆ 10 to the power of plus 38 ಬಂದ್ಬಿಡುತ್ತೆ. ಅಂದರೆ ನ್ಯೂಕ್ಲಿಯರ್ ಫೋರ್ಸ್ ಈಸ್ 10 to the power of 38 times gravitational. ಅರ್ಥ ಆಯ್ತಲ್ವಾ? So with this discussion, my dear students, you should be able to write, name any 4 fundamental forces in nature: strongest nuclear force, weak nuclear force, electromagnetic force, gravitational force. Just to understand the comparative strength, relative strength between these two, I have written this. Okay, with this you must say that weakest force is gravitational force, strongest force in the universe is nuclear force. Now, last discussion of the chapter is some basic fundamental laws in nature. Fundamental, or we say basic laws in nature. Means all these natural phenomena what you and we see around us, they must follow some basic laws, my dear students. Whatever the natural phenomena that you come across around you and around us, or any scientist, all these must follow some basic laws in nature. Without these basic laws in nature, we cannot explain, you cannot understand that some natural phenomena that appears or natural things that happens around us cannot be understood. Say for example, best example, a bullet fired from the gun. Now before firing the bullet from the gun, both are at rest. Means momentum is conserved here, momentum is conserved. Means initial momentum is 0. Means quantity of motion. In order to conserve that, means in order to maintain the momentum to be constant, when bullets are fired, you must say that gun recoils. But because of heavier mass of the gun recoil with lesser speed. Because of the smaller mass of the bullet fires with a greater speed to conserve the momentum. Say there is some stored energy. An arrow shot from a bow. What the person will do? He stretch the bow with an arrow. There is a stored energy. What type of energy? Potential energy is stored. Now what happened? Before firing that bow, before the firing arrow from a bow, both are at rest. That person has to make that arrow to reach certain target. To reach that target, he has to give some energy for that. He has to stretch. Means there is some stored potential energy. When that person leaves that arrow, what happens now? Arrow move forward with some greater speed. What happened there? One form of energy is converted into another form. Before firing, what is there? Total energy is 0. After the arrow is shot from a bow, to conserve the total energy, one form of energy must be converted into another form. Say energy stored in a dam. What kind of energy it is? Potential energy. Stored energy is potential energy. When it dropped from certain height, one form of energy gets converted into another. Potential energy is converted into kinetic energy. So there are some basic, say one more example. You have seen athletes performing some events in Olympic Games. Say there is a ballet dancer where can dance with good events. You and all the audience will be thrilled by looking at those events performed by an athlete. When the ballet dancer takes the arm and they rotate with some greater speed, what happens? They fold their arms inside. Once they fold their arms and legs inside, they gain greater momentum and they start rotating with greater speed. And with that greater speed, they won't stop. They have to stretch their arms. The ballet dancer has to stretch their arms and leg. When they stretch their arms, what happens? There will be an increase in the moment of inertia. Automatically, unknowingly, when they stretch their arms, angular speed gets reduced. It happens in order to conserve the angular momentum. Say there is a swimming event in athletics, my dear students, that from a certain height, a person dive into water. Simply, if he dives, he won't be selected for the event. From the beginning level itself, he will be thrown away. If he dive, no, he has to perform some events before touching the surface of water. He has to curl his body. He has to bend his body. He has to, when he bends his body, he will rotate with a greater speed, my dear students. But with that style, by bending his body, he should not hit the surface of water. Definitely, if he hits by bending his body into the surface of water, he will lose his life. No more his life. Means once he curls his body, what happens? There is some conservation. Angular momentum is conserved, my dear students. Angular momentum is conserved. What happens? When he curls his body, moment of inertia gets reduced. Angular speed will increase. But when he touches, he will stretch his arms and legs. When he or she stretch the arms and legs, moment of inertia will increase. Angular speed reduces and he will hit the ground at the lesser speed. So with this, there are some basic laws in nature. They are, one is law of conservation of energy. Conservation ಅಂದ್ರಪ್ಪ ರಿಮೇನ್ಸ್ ಮೊದಲು ಎಷ್ಟಿರುತ್ತೋ ಫೈನಲ್ ಅಷ್ಟೇ ಇರಬೇಕು. ಇನಿಷಿಯಲ್ 0 ಇದ್ದರೆ ಫೈನಲ್ 0 ಇರಬೇಕು. ಅದಕ್ಕೇನಂತ ಕರೀತಾರೆ? ಕನ್ಸರ್ವ್, ಕಾನ್ಸ್ಟಂಟ್ ಅಂತ ಕರೀತಾರೆ. ಎನರ್ಜಿ ಇ ಫೈನಲ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಇ ಇನಿಷಿಯಲ್. ಟೋಟಲ್ ಎನರ್ಜಿ. ಟೋಟಲ್ ಎನರ್ಜಿ ಇನಿಷಿಯಲ್ ಎಷ್ಟಿರುತ್ತೋ ಫೈನಲ್, ಇನಿಷಿಯಲ್ ಎಷ್ಟಿರುತ್ತೋ ಫೈನಲ್ ಅಷ್ಟೇ ಇರಬೇಕು. ಇನಿಷಿಯಲ್ 0 ಇದ್ದರೆ ಫೈನಲ್ 0 ಇರಬೇಕು. ಅದಕ್ಕೆ ನಾವೇನು ಕರಿತೀವಿ? ಕನ್ಸರ್ವ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಅಥವಾ ಟೋಟಲ್ ಎನರ್ಜಿ ಆಫ್ ಅ ಸಿಸ್ಟಮ್ ರಿಮೇನ್ ಕಾನ್ಸ್ಟಂಟ್. That you will study in detail while coming in the next classes. You must say what is the meaning of conservation. Means total energy of the system remain constant. Like that, there is law of conservation of momentum. Again, total momentum of the system remains same. P, it is denoted by letter P. Initial momentum should be is equal to final. The final is equal to, final momentum is equal to initial. Eradu baribodu. Last, law of conservation of angular momentum. That means it is denoted by letter L final is equal to L initial. L is symbol first. ಈಗ ಪಿ ಅಂದರೆ ಮೊಮೆಂಟಮ್, ಅದಕ್ಕೆ ಕೂಡ ವೆಕ್ಟಾರ್ ಕ್ವಾಂಟಿಟಿ. ಮೇಲೆ ಅರೋ ಮಾರ್ಕ್ ಬರೆದ್ರೆ ವೆಕ್ಟಾರ್ ಕ್ವಾಂಟಿಟಿ, ಇಲ್ಲಿ ಬರೆಯಲ್ಲ. ಎನರ್ಜಿ ಇಸ್ ಸ್ಕೇಲಾರ್ ಇರುತ್ತೆ, ಪಿ ವೆಕ್ಟಾರ್ ಅಂತ ಬರೀತಾರೆ. ಇನಿಷಿಯಲ್ ಮೊಮೆಂಟಮ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಫೈನಲ್ ಮೊಮೆಂಟಮ್. ಇಲ್ಲಿ ಕೂಡ ಫೈನಲ್ ಮೊಮೆಂಟಮ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಇನಿಷಿಯಲ್ ಮೊಮೆಂಟಮ್, ಆಂಗ್ಯುಲರ್ ಮೊಮೆಂಟಮ್. ದೀಸ್ ಆರ್ ಸಮ್ ಬೇಸಿಕ್ ಲಾಸ್ ದಟ್ ಎವ್ರಿ ಡೇ ಎಕ್ಸಿಸ್ಟ್ ಆಲ್ ಅರೌಂಡ್ ಅಸ್ ಇನ್ ದ nature. So my dear students, with this we come to an end of first chapter, that is a physical world. Maximum in the board exam you will get a 2-mark question from this. Don't neglect. 2 marks are marks worry ಮಾಡಬೇಡಿ. Marks will come definitely. Marks will follow you once you follow the concepts. You be confident in understanding the concepts, follow the subjects. Subject and approach ಮಾಡಿ. ನಾನು ತುಂಬ ಚೆನ್ನಾಗಿದ್ದೀನಿ, ನೀನು ತುಂಬ ಚೆನ್ನಾಗಿದೀಯಾ, ಬ್ಯೂಟಿಫುಲ್ಲಾಗಿ ಕಾಣ್ತಾ ಇದ್ದೀನಿ ನಾನು, ಫಿಸಿಕ್ಸ್ ನನ್ನ ಹತ್ರ ಓಡಿ ಬರಲ್ಲ. ನನ್ನ ಹತ್ರ 1,000 ಕೋಟಿ ರೂಪಾಯಿ ಇದೆ, ನನ್ನ ಹತ್ರ ಏನೂ ದುಡ್ಡು ಇಲ್ಲ, ಇಲ್ಲ ಅವನ ಹತ್ರ ದುಡ್ಡು ಜಾಸ್ತಿ ಇದೆ, ನಾನು ಫಿಸಿಕ್ಸ್ ಅವನ ಹತ್ರ ಹೋಗಬೇಕು, ಹೋಗಲ್ಲ ವಿದ್ಯಾರ್ಥಿಗಳೇ. ಸಬ್ಜೆಕ್ಟ್ ವಿಲ್ ನೆವರ್ ಫಾಲೋ ಯು. ವಿ ಹ್ಯಾವ್ ಟು ಫಾಲೋ ದಿ ಸಬ್ಜೆಕ್ಟ್ಸ್. ನಾವು ಲವ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಏನು ಲವ್ ಅಂದರೆ ಸಬ್ಜೆಕ್ಟನ್ನು ಲವ್ ಮಾಡು, ಪ್ರೀತಿ ಮಾಡು, ನಮ್ಮನ್ನು ಕಾಪಾಡುತ್ತೆ. ಸಬ್ಜೆಕ್ಟನ್ನ ಇಷ್ಟಪಡು. ಫಿಸಿಕ್ಸ್ ನನ್ನನ್ನು ನೋಡಿ ಇಷ್ಟಪಡಲ್ಲ. ಸಬ್ಜೆಕ್ಟ್ ವಿಲ್ ನೆವರ್ ಲವ್ಸ್ ಯು, ಲವ್ಸ್ ಮೀ. ಸಬ್ಜೆಕ್ಟ್ ನೆವರ್ ಲವ್ಸ್ ಮೀ. ವಿ ಹ್ಯಾವ್ ಟು ಲವ್. ಪ್ರೀತಿಯಿಂದ ನೋಡ್ಬೇಕನ್ನ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಅರ್ಥ ಮಾಡ್ಕೊಂಡು ಹತ್ರ ಮಾಡ್ಕೋಬೇಕು. ನಮ್ಮನ್ನು ಅಂಟಿಸ್ಕೋಬೇಕು ಅದನ್ನು, ಸಬ್ಜೆಕ್ಟನ್ನು. ಮುಂದೆ ಊಟಕ್ಕೆ ಹಾಕುತ್ತೆ, ಎಲ್ಲೋದ್ರೂ ಊಟಕ್ಕೆ ಹಾಕುತ್ತೆ ಜಗತ್ತಿನಾದ್ಯಂತ. ನೆನ್ಪಿಡ್ತೀರಾ ಇದನ್ನು ಹೇಳಿದ ಮಾತನ್ನು? ಓಕೆ.